YouTube live. Huh?
Full slide ಬಂತಾ? Full slide ಬಂತಾ? Start ಮಾಡಿ. Good evening, everyone. I am Chaitra P, research scholar, Department of Physics in Bangalore University. Today I am going to give my proposed research work. I am working under the guidance of Dr. Kamsali Nagaraja, Associate Professor, Department of Physics, Bangalore University. Title of my topic is Study of Ionospheric Electron Content over the Indian region. Let us see the introduction part. Ionosphere is the ionized layer of the Earth's upper atmosphere, which extends from 50 km to 1000 km during the daytime. The ionosphere constantly varies with the time and the day. It varies with the seasons, geographical locations, even with the solar radiations, ionosphere concentrations will vary. The ionosphere is divided into three major regions, that is E layer, F layer, D layer, E layer, and F layer, based on the electron density profile. During the daytime, F layer is further divided into F1 layer and F2 layers, whereas during the night time, D layer is completely absent and F1 and F2 layers merge to form an F layer. This you can see in this figure, where y-axis represents the altitude in kilometers and x-axis represents the electron density, concentration of electrons. And this ionosphere is also categorized into various regions based on the ion contents along the latitudes, that is low latitudes, mid latitudes, and high latitudes. Low latitude means from plus 30 degree to minus 30 degree, and mid latitude means from 30 degree to 65.5 degree. High latitude means 65.5 degree to up to 90 degree, that is the polar regions, that will be named as an high latitude ionospheric regions. Here we can see the ions and electrons are present in the ionosphere will affect the propagation of electromagnetic waves. Each layers in the ionosphere has a different characteristics and it will affect the radio wave communication in different waves. The ionosphere is dynamic systems controlled by the many parameters like the electromagnetic emissions, acoustic motions of the atmospheres, and the various geomagnetic fields, and it will also affect by the tsunami waves, earthquakes, and other parameters also. Here I have shown the variation of electron density during the night time, and also the concentration of ions at a different altitudes. Here the GPS signals transmits the satellites, transmitted from the satellite. It will travel through the ionosphere. Since the ionosphere is a dispersive medium, that is different frequencies travels with a different velocities, and this will velocities will be affected, GPS frequencies will be affected by the ionospheres, and this effect is usually referred as an ionospheric delay and ionospheric errors, and which will be studied using a receiver placed at the surface of the Earth. And also this magnitude of ionospheric delay is proportional to the total electron content and inversely proportional to the transmission frequency. The total electron content is nothing but the total number of electrons in a column with a cross section of a 1 meter square. That is, you can see in this figure. And the TEC measured in a TEC units. One TEC unit is equal to 1 into 10 to the power of 16 electron per meter square. And by studying this TEC units, it will provide the ionization in the atmosphere, and also it will help for the practical applications of a radio wave propagations. And TEC will be cannot be measured directly. What we are measuring is a slant TEC, slant total electron content, which is nothing but a total electrons TEC measured along the path of the signal, which is referred as a slant TEC. And this, by obtaining the slant TEC, we can derive the vertical DEC, which will be explained in further slides. The objectives of our studies are the study of TEC during a diurnal variation of TEC monthly and a seasonal variation of TEC will be studied, and temporal and spatial variabilities of TEC will be studied. And the obtained TEC will be compared with the IRI models of 2007, 2012, and 2016. After these studies, an effort will be made to develop a model with the suitable incorporations into an IRI model. And also TEC irregularities for the Indian regions will be studied. And the TEC variation in a low latitude ionospheric regions over the Indian regions will be studied here. And ionospheric stimulations and characterizations of a GPS signals will be studied. And also the effect of TEC by the solar activities and coronal mass ejections will be studied here. And these are the brief objectives, and we will make an attempt to cover all the objectives. Coming to methodology part, slant total electron content, which will be converted into a total electron content using these formulas. Firstly, the slant total electron content is nothing but the path of total electron content which is received at a signal path, that is in this path, which is explained in the equation where the psi dash is zenith angle between the IPP, that is international Persis point, sorry, ionospheric Persis point, and which is at a height of okay, and the angle xi dash is the angle between the ionospheric precise point and from the path of the signal, whereas xi is the zenith angle from the that is from receiver to the satellite path. Here RE is the radius of the earth, and HM is the distance from the surface to an ionospheric precise point. The processing and analysis of data. Here we receive the data from a various GNSS archives, and those GPS data will be in the form of a RINEX format, and these RINEX format will be used to estimate TEC by using the software tools like a TQC, that is TQC, that is translating, editing, and quality checking, and using the Gamut software and RTKLB and GPS TK C++. These are the software tools used for the calculation of a TEC. And these estimated TEC will be analyzed by plotting it with respect to various heights and with respect to various latitudinal regions. And this obtained TEC data will be compared with the IRI model. Later, these will compare after the comparison of the data, we are going to obtain certain results and conclusions. Here, this is the ionogram, real-time ionogram model, which gives the it represents the different layers of the ionospheres. You can see this represents during the the x-axis represents the time scale, and y-axis represents the height, and we can see the electron density of electrons, which is represented in the different colors. The concentration of electrons, which is represented in the colors. This is the global variation of a TEC, and this is the TEC values, where the over the Indian region, we can see the TEC variation is around 20 to 25 TEC units. And as we move to the upper portion of the latitudes, the TEC value will goes on decreases. This is mainly due to the equatorial ionization anomaly effect. And these are the reference part I have quoted.